Hello guys, good evening. Welcome to another section of the Azure Nigeria User Group Community event. And today's event will be talking about administering visual networks in Azure. So most of you already know what a visual network is and how important that is in building application in Azure Cloud. So whether you're building a PaaS solution or SaaS solution. So we'll be discussing about visual networks and also about network security groups and also about Azure Firewall and then further with Azure DNS. And then I would show a lab on implementing visual networks. So basically, these are just topics that is widely known in the area of infrastructure as a service within Azure environments. So I'll be talking about the networking, visual network, setting it up, and then configuring the network security groups, and then the firewall, how to set up the firewall around it, and then a DNS. So for starters, would configure the visual networks, and then in this demonstration or in this introduction, we'll plan for visual network and creating subnets, how to create visual network itself, and then plan for IP addressing, also creating public IP addresses, and also associating public IP address, and then likewise with private IP addresses. So with planning with about visual networks, so you have a kind of an environment where you want to build your application in a secured way. So you have an on-premises environment, and from the on-premises environment, you have like a set of security around the systems you're using, how you want to configure your applications, and how you want your application to run. So let's say you have ERP systems, CRM systems, critical systems used by your enterprise. And then you will need a way to interact or to connect in a safe way. So, and that's where visual network comes up. So you need your own communication in a private way that only you and also the entities or the policies you want can interact with and do business with your organization. So within a visual network, we have subnets, and then we have the NIC. So, and within that encompasses a visual machine. So you have a visual machine in place, and then you have a subnet, and then you have network cards. And then within that, you have a network security group in this ecosystem. So in a nutshell, you would say visual network is just a logical representation of your own network, which is created dedicated with a private cloud-only visual network, and securely extends your data center with the visual networks. And likewise, it enables hybrid cloud scenarios. So in creating a subnet, so Microsoft reserves 5 instances IP addresses within each subnet. So a visual network can be segmented into one or more subnets, and its subnets provides kind of a logical division within your network. And subnets can help improve security, increase performance, and make it easier to manage the network. And then each subnet must have a unique address range and cannot overlap within other subnets in the VNet in the subscription. So in creating a visual network, this is just a quick demonstration using creating a visual network using the Azure portal. So one thing is very important, you need to always plan to use an address space that is not already in use in your organization. So either on premises or in other VNets. So even though you plan for an VNet to be cloud only, you may want to make a VPN connection to it later. So if there's any overlap in address spaces at that point, you would have to reconfigure or recreate the VNet. And then the next section is about focus on IP addressing. So planning your IP addressing. So you can design an IP addressing schema for your Azure deployments. So as a best practice, you may describe to separate dynamically and statistically assigned IP resources into different subnets. And then an IP addresses are never managed from within a virtual machine. So you have a VNet, an on-premises network, or say an express route, and then there's a private address you configured, and that's for an Azure resource itself. And then for the public outbound, you have like a public IP addresses. So for the public facing services, say for instance, your environment on Azure resource needs to allow inbound traffic that goes through the internet. So private IP address used within an Azure virtual network and your on-premises network when you use a VPN gateway or express routes or express route circuits to extend your network to Azure. And public IP address is used for communication with the internet, including Azure public-facing services. So next about in creating a public IP address, so you could you have like available in IPv4 or IPv6 or both. So you can see you could get like a basic or versus standard SKU, dynamic or versus static, zone redundant, standard SKU, also range of continuous addresses available as a prefix. Also, you can associate public IP addresses. So you can have like a visual machine. So you have a visual machine with a NIC, and that is a dynamic, so also static. For load balancers, we have a front-end configuration, and this serves for dynamic and static. You have a VPN gateway as well, so gateway IP configuration, and that serves for dynamic and static. So it's good to know that a public IP address resource can be associated with visual machine network interfaces, internet-facing load balancers, VPN gateway, and application gateways. And then, so the dynamic is by default. So Azure assigns the next available unassigned or reserved IP address in the subnet address range. And also the static, you can select and you assign any unassigned or reserved IP address in the subnet address range. So we look at a bit of a demonstration. So we'll create a vision network in the portal, and then we'll create a vision network with PowerShell. That could be an option. So next topic is configure network security groups. So the lab, if we have time, so we can do that and I can demonstrate that to you. Or we can do that in the next event. So a network security group is just like a set of a policy definition where your subnet and your VNet coexist. And then you need to define rules, so NSG rules, that governs or controls the setup of your infrastructure, your network. So you will need to create security rules, associate the NSG to a subnet or network interface, and evaluate effective security rules. So to simplify management of security rules, it's recommended that you associate a network security group to individual subnets rather than individual network interfaces within the subnet. So in implementing network security groups, it limits network traffic to resources in a visual network, leads the security rules that allow or deny inbound or outbound network traffic, associated to a subnet or a network interface, and can be associated multiple times. So this is a network security group. And next, in determining the NSG rules. So security rules in NSG enable you to filter network traffic that can flow in or out of the visual network subnets and its network interfaces. So there are default security rules. So and you cannot delete those default security rules, but you can add other rules with a higher priority. So you can see here the priorities for the inbound security rules, and then the priorities for the outbound security rules definitions. So for connection, for inbound connection with via RDP inbound, so this port has to be open. So for port 3389, it's allowed. And then for any port, you have to deny all inbound coming in. So that's basically how to determine NSG rules and how to set that. So in determining NSG effective rules, so the NSG are evaluated independently for the subnet and the network interface card. And so you have the subnet, this is the NIC, and you have the NSG1 and the NSG2. And allow rule must exist at both levels for traffic to be admitted. You can use the effective rules link if you are not sure which security rules are being applied. So in creating NSG rules, so you need the source, and then you need the destination. And then you have to define the services. So the services could be HTTP, SSH, RDP, DNS, and then you define the priority. So the lower the number, the higher the priority. So next is about Azure Firewall. So Azure Firewall basically is how you prevent unwanted access by defining or placing a firewall that governs access to your network. So we'll talk about that. So we'll determine the Azure Firewall rules. We'll create Azure Firewalls, create Azure Firewall rules, and then we'll take a summary. So in determining Azure Firewall rules, first you need to talk about the uses. So for instance, you have an environment. So you have an environment, and then you have like a machines in a resource. So spoke 1 and spoke 2 environment. So network topology spoke, and then you have a firewall, and then you have an on-premises environment. So you have to define a wall within your cloud environment where your resources reside. So, and that is protected, and that protects access from the web to your environment, yes or no, and that's what the firewall does. So it protects your environment, it's kind of a buffer between the public web and your environment and your network. So Azure Firewall is built in high availability with unrestricted cloud scalability. It's threat intelligence-based filtering, and that is fully integrated with Azure Monitor for logging in and analytics. So this kind of a hub and spoke network topology in Azure. So in creating Azure firewalls, you need a hub and spoke network topology, which is recommended. So you have a hub visual network, and then you have the bastion to connect, and then you have the firewall and a VPN gateway. So shared services are placed in the hub virtual network. And then here, each environment is deployed to a spoke to maintain isolation. And as with networking, isolation is very important. And then you can have a peered network, peering that exists, and then you can monitor that. Get diagnostics that feeds into Azure Monitor. You can monitor what's going on. You could observe there's like a forced tunneling. You could do your paired virtual networking between your spoke virtual network on the hub virtual network. So in creating Azure Firewall rules, Azure Firewall Manager centralizes firewall management. The firewall policy container rules and settings to control access. So the NAT rules allow incoming connections. Network rules contain source and destination addresses, protocols, and destination ports. And you can also have application rules that provide qualified domain names. So next, we'll look at Azure DNS. So within this topic, we'll look at identifying the domains and the custom domains, verifying custom domain names, creating Azure DNS zones, delegate DNS domains, adding DNS record sets, and plan for private DNS zones. And also determine private zone scenarios, and then demonstrate DNS name resolution. So what is Azure DNS? So basically, Azure DNS is a way you have to you have to specify an environment based on the domain you have from Microsoft. So the domain has initially a domain name in the form of, say, domain name or Microsoft.com. So you can customize or change the name. So say after the custom name is added, it must be verified to demonstrate ownership of the domain. So you can verify custom domain name. So verification demonstrate ownership of the domain name. So you can add like a DNS record, MS or TST record that is provided by Azure into your company's DNS zone. Then Azure will now query the DNS domain for the presence of the record. So normally this takes quite a while, taking like minutes or hours in doing that. So in creating a DNS zones, so the DNS zone basically hosts the DNS record for a domain. So in a case when you have like a multiple zone share the same name, each instance is assigned different name server addresses. So in delegating DNS domains, so you can, when delegating a domain to Azure DNS, you must use the name server names provided by Azure DNS. Once the DNS zone is created, update the parent registrar. For child zone, register the DNS records in the parent domain. So next is adding the DNS record sets. So a record set is kind of a collection of records in a zone that has the same name and are the same type. So you could add 20 records to any record set. A record set cannot contain two identical records. So next is planning for private DNS zones. So when you use your own domain names, they can provide name resolution for VMs within a VNet and between VNets. Automatic host name record management removes the need for custom DNS solutions. So private zone scenarios, determine a private zone scenarios. So DNS resolution in VNet is private and not accessible from the internet. DNS requires across the visual networks are resolved, and the reverse DNS queries are scoped to the same visual network. And then lastly, demonstration, so DNS. So how to create a DNS zone, and how to add DNS record set. You can now view your name servers, test the resolution, and then explore DNS metrics. So the lab for next event is we show a lab on implementing visual networks. So the scenarios for to carry out this task is like first, task one, you create and configure visual network. Two, deploy virtual machines into the visual network. And three, configure the private and public IP address of Azure visual machines. And then four, you configure the network security groups. Five, you configure the Azure DNS for internal name resolution. And then lastly, you configure the Azure DNS for external names resolution. So next, we're going to architectural design. So this is a network architectural design. So in task one, we create a configured visual network. So there's a visual network. And within a visual machine, you have the visual machines with the NIC. And then you have two subnets, subnet 1 and subnet 0, with their own respective private IP. Now, this NIC, these two subnets, subnet 0 and subnet 1, has an NSG. And then there's a DNS zone as well. And then you have the domain name, the DNS, so contoso.org, in this case, contoso.org. So that's basically it. So in the next event, we'll do the lab for this topic. That's it, guys. Take care. See you in the next event. Bye-bye.